Good morning. This is Hope Reactor. Now, let's begin today's news.
The satellite made of wood. Japan's quiet answer to space pollution. Introduction. When we think about space technology, we usually imagine metal, aluminum panels, carbon fiber, solar arrays, rocket engines, cold machines floating above Earth. We almost never imagine wood. Wood belongs to forests, homes, furniture, temples, old tools, traditional craftsmanship, not outer space. But Japan has challenged that assumption. In 2024, researchers from Kyoto University and Sumitomo Forestry launched something the world had never seen before: a wooden satellite. Its name is LignoSat, and while it may sound like a strange experiment, it points to a much bigger question. Can humanity explore space without damaging the planet below? The hidden problem. Satellites are now part of everyday life. They guide our phones. They support weather forecasts. They help ships and airplanes navigate. They monitor disasters. They connect people across the world. Modern life depends on them. But satellites do not last forever. When a satellite reaches the end of its life, it often re-enters Earth's atmosphere and burns up. For a long time, this seemed like a clean ending. The satellite disappears. The sky stays clear. Problem solved. But scientists are now looking more carefully at what actually happens during re-entry. Many satellites are made with aluminum. When aluminum burns high in the atmosphere, it can create tiny aluminum oxide particles. Researchers are still studying how these particles may affect the upper atmosphere and ozone layer over time. The concern is simple. If thousands or even tens of thousands of satellites are launched in the coming decades, their re-entry could become a new environmental issue. Space pollution may not only happen in orbit, it may also return to Earth. Why wood? This is where the story becomes surprising. Japan asked a question that sounds almost impossible. What if part of a satellite could be made from wood? At first it sounds wrong. Wood burns, wood rots, wood bends, wood cracks. But those are Earth problems. In space, there is no oxygen. Without oxygen, wood does not burn the way it does on Earth. There are no insects, no rain, no moisture, no ordinary decay. In some ways, space may be kinder to wood than Earth is. But that does not mean space is easy. A satellite in orbit faces extreme temperature changes. It moves in and out of sunlight again and again. It is exposed to radiation, solar wind, vacuum, mechanical stress. So the question was not simply, can wood survive? The real question was, which wood can survive? The search for the right wood. Researchers tested several types of wood. They needed something light, stable, strong, and resistant to shrinking or warping. The material that stood out was Honoki, a type of Japanese magnolia. This choice was not random. Honoki has been used in Japan for centuries. One famous use is the sheath of a Japanese sword. A sword sheath needs to be light. It must not damage the blade. It must hold its shape. It must be stable over time. That same quiet strength made Honoki interesting for space. This is one of the most beautiful parts of the story. A material once used to protect a sword was now being tested to protect space technology. Japanese craftsmanship in orbit. LignoSat was not only about wood, it was also about how the wood was joined. In normal engineering, we might expect screws, bolts, or glue. But in space, glue can create problems. In a vacuum, some adhesives may release gases. Those gases can contaminate sensors, cameras, and delicate equipment. So the team used a traditional Japanese wood joining technique. No screws, no glue, just precise craftsmanship. The wooden panels were fitted together, using a method inspired by traditional joinery. This is where the project becomes more than a science story. It becomes a cultural story. Japan did not solve a space problem only by inventing something completely new. It also looked backward, to woodworkers, to old techniques, to materials trusted for generations. Then it carried that knowledge into orbit. LignoSat. LignoSat is small. It is a CubeSat, about the size of a small box. But its meaning is much larger than its size. It was developed by Kyoto University and Sumitomo Forestry. It was launched to the International Space Station aboard a SpaceX mission in November 2024. Then it was deployed into orbit from the ISS. Its purpose was not to replace every satellite immediately. That would be unrealistic. Instead, LignoSat was a first test, a proof of concept. Could wood survive in orbit? Could it hold its structure? Could it become part of a more sustainable future for space technology? That is why LignoSat matters. It is not the final answer. It is the first door opening, the scientific breakthrough. The key lesson is this: wood is not just an old material. It is an advanced natural material. It has strength. It has flexibility. It has low weight. It stores carbon while it grows. And when it burns, it may produce fewer harmful residues than conventional satellite metals. Of course, wooden satellites will not replace all spacecraft tomorrow. Satellites still need electronics, antennas, power systems, thermal control, communication equipment. LignoSat itself still includes non-wood components, but the experiment shows that wood may have a role in future spacecraft design, not as decoration, not as symbolism, as engineering. That is the important shift, the Hope Reactor view. At Hope Reactor, what makes this story powerful is not just the technology, it is the mindset. When many people imagine the future, they think it must be built only from new materials, new machines and new systems. But LignoSat reminds us of something different. The future does not always begin by abandoning the past. Sometimes it begins by seeing the past with new eyes. Wood is one of humanity's oldest materials. We used it to build homes, ships, tools, temples, bridges, instruments. And now, a version of that same material has reached space. That is not nostalgia. That is innovation with memory. Japan's quiet strength. This project also reveals something important about Japanese engineering. It is not always loud. It does not always look dramatic. Sometimes it appears in precision, patience, material knowledge, craftsmanship, a refusal to waste what already works. The world often celebrates the biggest rocket, the fastest computer, or the most powerful machine. But LignoSat tells a different story. Sometimes the future is not bigger. Sometimes it is smarter, lighter, cleaner, and more thoughtful. A wooden satellite may sound small, but the idea behind it is huge. It asks whether space development can become more responsible. It asks whether tradition can help solve modern problems. It asks whether sustainability should be part of space exploration. From the beginning, not added later. Ending. Space is often described as the final frontier. But maybe the next frontier is not only about going farther, maybe it is about going wiser. If humanity is going to build a future beyond Earth, we have to think carefully about what we leave behind. In orbit, in the atmosphere, and on the planet we still call home. LignoSat does not solve every problem, but it gives us a new direction. A wooden satellite, born from Japanese science and traditional craftsmanship, has shown that old materials can carry new dreams. And maybe that is the real message. The future does not always arrive in metal. Sometimes it arrives in wood. What do you think? Could wooden satellites become part of the future of space exploration? Or is this only the beginning of a much bigger idea? Let me know in the comments. And if you want more stories about humanity's problems and the hope hidden inside them, follow Hope Reactor for the next discovery.